that is programmable logic array. In the programmable logic array, we have a programmable AND gate and OR gate. That means in the programmable logic array, we have both programmable AND gate as well as programmable OR gate. So before going to further designing, we should know the step. So first step is make the truth table. So if you are having some statement, then based on that statement, first draw the truth table. That will be the first step. In the second step, we need to find out the minimal SOP form, minimal SOP, minimal sum of product form, either by using the theorems or by using the K-map. You can minimize the expression for its output. In the third step, we need to find out the number of input buffers required. Input buffer required. In the fourth step, we calculate the number of programmable AND gate required. And in the fifth step, we will calculate the number of programmable OR gate required. That are the 5 steps we need to follow to design any circuit based on PLA. So based on this PLA, we are taking first example. So for example, in this, we have already a truth table. So first I'm drawing the truth table. For example, we have A, B, C as the input, and we have Y1 and Y2 as the output. As we are having 3 inputs, how many possible combinations are possible? That are 8. So I'm writing all the 8 possible combinations if you are having the 3 input in the truth table. That is 0, 0, 1, 1, 0, 0, 1, 1, and this is 0, 1, 0, 1, 0, 1, 0, 1, right? So this is the input. Now, for example, in the truth table, they already mentioned the value of Y0, like Y1, that is 0, 0, 0, 0, 1, 1, 0, 1. And this is 0, 0, 0, 1, 0, 1, 0, 1. For example, truth table is given in the numerical. So my first step is already solved because we already have the truth table with us. The second step is to write down the minimal SOP form for its output. For example, I want to write down for Y1. So how I can write down the Y1? Wherever its value is 1, for that we have to write down its combination. Okay. If A is 1, that means it's a normal form, and if 0, that means it's a complement form. So if you want to write down the expression for Y1, then I will write down A, B bar, C bar. Similarly, for the next combination where Y1 is 1, for this it is 1, 0, 1. That means it is A, B bar, C. Similarly, the last one is A, B, C. So now we have this expression and we have to minimize it. Okay. How we can minimize? Either by using the theorems or by using the K-map. Okay. So here I'm using the direct theorem, so it will be easy to understand. Okay. So here, if you want if you can take the common terms here, that is A, B bar. So it will be C bar plus C plus ABC. And by the theorems, we know that C bar plus C is equals to 1. So you can write down Y1 is equals to AB bar plus ABC. After that also we can minimize it. If you take A common here, then it will be B bar plus BC. By using the distributive property, I can also write down as B bar plus B, and this is B bar plus C. And as you know that B bar plus B is equals to 1, you can also write down as A B bar plus A C. So this is the expression that we are getting for Y1. This is Y1. Now, same thing we have to do for the Y2 also. So Y2 can be written wherever Y2 is 1, right? So here Y2 is 1, A bar BC. So this is A bar BC plus second term where your Y2 is 1 is this one, 101. So 101 can be written as A B bar C plus, and the third time Y2 is 1 when it is 111. That means ABC. So it is ABC. Now you can further solve by using the theorems like this: A bar BC plus, this is AC I'm taking common, so it will be B bar plus B. So I can directly write down this is AC plus this is A bar BC. Now here also we can further solve by taking C common. So this is A bar B plus A, and I am taking C common. And after applying the distributive property, I can also write down as A bar plus A, and this is B bar B plus A C. So here, as we know that A bar plus A is equals to 1, so I can also write down as BC plus AC. So now we are ready with the minimal expression, and that was our second step. Okay. So in the second step, we was finding the minimal SOP form for its output Y1 and Y2. In the third step, we have to find out the number of input buffer required. So before going to find out the number of input buffer required, we should know what is the meaning of buffer. So buffer is showing like this. The symbol is like this, where we provide certain input. For example, I am providing A here. In the output, we will have two terminals, one for the normal form, another one with a bubble that will give a complement form of that input. Okay. And the number of input buffer required is equals to the number of inputs. So in our truth table, if you check how many inputs are there, A, B, C. So we require 3 input buffer, right? And in bracket also I'm writing A, B, C. As we are having 3 inputs, we require 3 input buffers. Now, after this, we have to find out the number of AND gates. So in the fourth step, we have to find out number of programmable AND gates. And this is more important because here we require the expression of its output. Y1 we already calculated as A B bar plus AC. Similarly, we calculated Y2 is equals to BC plus AC. Here you have to find out unique minimal terms, unique SOP terms. In the both the expression, you have to find out the number of unique SOP terms. So like AB bar is the unique term, AC. That means you have to consider only one time. Okay. BC is the third term. So here I am writing AB bar is the one term, second term is AC, and third term is BC. So we have 3 unique SOP terms in both the output. So we require 3 programmable AND gate. Okay, this is the important part. You have to consider only the unique SOP terms. Now we will see the fifth step, that is the number of programmable OR gate. Programmable OR gate. Programmable OR gate is equals to the number of output. It is equals to the number of output. As we have two output Y1 and Y2, so we require only 2 programmable OR gate. So now all the 5 steps we completed, that is the number of input buffer required is 3, number of programmable AND gate required is 3, number of programmable OR gate required is 2. Now we can start designing the circuit. For designing the circuit, always start with the number of input buffers. As we have seen, we require 3 input buffer for its input. We are drawing it first, that is A, and draw the straight line like this. Similarly, the second terminal will give you A bar. Here, second input, that is B here. So I'm writing if this is B and this terminal is direct. Another one is with the bubble. Similarly, you have to draw for C, and this is C. One will give direct terminal, another one with a bubble. After this, based on the number of programmable AND gate, you make a line like this. So as we are having 3 AND gates, so I'm just changing the color so it will be more clear. Yes, here I am drawing one straight line like this, and this is for the AND gate. As we are having 3 AND gate, I am making 3 straight lines like this. At the bottom, here we are drawing one AND gate. This is the second AND gate, and this is the third AND gate. Okay, and here, as we are having the 2 OR gates, that's also we have to draw. 2 OR gates will be drawn like this. One OR gate here, another OR gate here. First one is for Y1, another one is for Y2. Now you see we have drawn the architecture of this circuit diagram, but here we have to make a crosses. So crosses is indicating the crosses will indicate the programmable and 0 indicates the fixed. But in the PAL, we have both the AND gate and OR gate as programmable. So it will be showing by the crosses. So first min term that we are having is AB bar. So here we make a cross A and this is B bar. Here you write down A, this is B bar. And what I will get here? I will get AB bar. This is AB bar. Similarly, the second terminal is AC, so that I will draw it as A, and this is the another one that is C. So that is AC. Similarly, the third minterm was BC, so here I will draw one B, and this is C. This is BC. Now, in the output Y1, we was having AB bar and AC, right? Y1 was AB bar plus AC. Second one is BC plus AC. So BC plus AC. Okay, this is the complete diagram for our designing PLA.